we have seen what is discrete probability distribution and what is continuous probability distribution. In the first lecture on this topic only, I explained to you what is discrete and what is continuous probability distribution. So probability distribution that is associated with a continuous variate, this is a continuous variate, is called continuous probability distribution. Okay, but there is a very conceptual difference between discrete probability distribution and continuous probability distribution. Why? Let's say the discrete one. In discrete, we have a finite number of values. That can be 1000 or 100 or 10 or 1 million, but this is finite. So if you take the probability, let's say we have 100 values and we have to see whether what is the probability of this. That will be 1 by 100. If all are mutually exhaustive and all conditions are met, this will be 1 by 100. So this is 1 by 100. But if we have 1 million, let's say this is the value and all are mutually exhaustive and all, then the probability will be 1 by 10 to the power minus 6. So then as the number of values that the random variable takes, as it gets increasing, the value of probability becomes lower and lower. So for a continuous distribution, probability is practically zero, because if you say there are 1 billion points and you have to find the probability of 1 point, that is practically zero. So what we do in case of continuous probability distribution, we don't take the probability of the variate x at a particular value a. Instead, what we do, we take like this, let the variate be x, then we take this x minus half of dx, this is dx, the what we know in calculus, a small value, and less than x plus half dx. So therefore, the probability distribution of the continuous variate is defined like this: x lying between x minus 1 by 2 of dx, x plus 1 by 2 by dx. That is, if x is this point on that continuum, if x is this point, then what we do, we take it from half dx minus half dx to x plus half dx. That is, this gap is dx. So what we do, we don't take, it is not discrete, so we cannot take x at equal to this point. What we'll do, we'll take from this point to this point in a region. This is the definition of probability distribution for a continuous variate, and this is given as fx dx, where fx is called the density function, the probability density function, fx. Okay, and since we have fx, we'll have a curve. This curve is called probability curve. We had seen the properties of discrete probability distribution. We just saw fx, that is the probability density function. What are its properties? The first property is, there what we had sigma pi equal to 1, I equal to 1 to n. Here what we have, this is minus infinity to infinity, fx dx is equal to 1. What is the meaning of this? Let's say this is x and this is your function, then we have frequency curve. So from minus infinity, I'm just dropping this coordinate. Let's say this is minus infinity and this is plus infinity. So if we take the integration of this curve from here to here, that is the area shaded by this curve and x coordinate, this is equal to 1. This is the meaning. That is, the total probability is equal to 1. That is the basic definition of probability. And second is, we had seen there that pi is greater than or equal to 0. That is, probability cannot be negative. Similarly, here we have fx is greater than or equal to 0. It cannot be negative. So these are the properties of probability density function. we had seen discrete distribution function, that was fx. Similarly, we define the distribution function for continuous variate. It was like this, less than equal to x. There the value was, we had written I equal to 1 to x pi. Here what we get in continuous form, this is given as minus infinity to x, this is x, fx dx. That is, we had just seen the curve. So if this is, let's say this is minus infinity and this is x, so area between this to this, the area shaded is equal to the density, distribution function for this continuous variate. So we have properties of this. What are they? First property is, this is integration this. So what if we take dfx of dx, d of fx, d by dx of fx, that is f dash x. What this will show? This will show the slope of the curve. So what is the curve? F dash of x will be simply fx. Clear? Why? This is integral. So if you take the derivative, it will be fx only. And we know that fx is greater than equal to 0. We have seen the property of fx, that is greater than equal to 0. So from here what we get? That the slope is greater than equal to 0. That is, this is a non-decreasing slope. That is, the curve is non-decreasing. It can have value up to this only or above this only. It will always increase, it will never decrease. It can be like this, but it cannot be like this. This is the meaning of this property. This is first. Second, we define f of minus infinity to be equal to 0, and similarly we have f of plus infinity, we define it to be 1. Clear? We have the third property, which is very useful, which is very handy in solving problems. The fourth property is the distribution function of x, that is greater than equal to a and less than equal to b. So how do we find this? This is equal to, this is the upper limit, this is the lower limit. So what we'll do, we'll go from minus infinity to b. This way, what we'll get? We'll get, let's say this is a, this is b. So when we take the integration from here to here, we get this value. Okay, and then what we do, we subtract this part, then we'll get from a to b, that is minus infinity to a fx dx. A to b, we have taken from minus infinity to b and then minus infinity to a. So what we get? We get this value, this area, this shaded area. So we get the distribution function for a to b. Clear?